so the rest of this virtual class session time gonna be spending on what's been fun for me, problem solving with the ChatGPT 4.0. Let me just set it up. I need to make sure test student can access this. I don't think I didn't clear these yet, so let me clear them. And I think it's been a couple weeks since I last did this, so I might be a little bit rusty, but my advice to you, and this is really one of the ways in which I'm demonstrating ChatGPT, use of ChatGPT in a way where I think you might actually use it this way, and this might actually be perfectly fine and will support your learning of physics. Because with a powerful tool like a generative AI, it can be abused. When you have a really sharp knife that can be used to cut yourself, it's like a morally value neutral. What makes a tool a good tool is the person using it. And if you intend to use this powerful tool of generative AI in a way that helps your learning, it can actually help you learn. And what I've been advising you is you have to make it good. You have to give it a proper prompt so that it won't just give you the answers right away. It'll walk you through the steps so that you'll be more likely to, one, remember it, and two, hopefully understand it so that actually helps you remember it better. So let me start out with a prompt. So I'll say, hi, I'm back. I'm wrapping up my mechanics, general physics with the calculus class. We started on applications this week. And as I'm working through the homework set, I'm really trying to make sure that I'm learning, because I'm going to be asked these questions again in oral exam, and I need to understand and remember enough for the exam. So, will you help me? It'll say yes. I'm just role playing. and so let me pick a few questions. We got 30 minutes, and just to test ChatGPT by just giving it a question and see if it'll just answer from. Now, by the way, question question one, for which there's like 6 different questions. It's just reading check. So make sure you can answer it. If you can answer it, that probably means you've read it through the textbook fine. Here, maximum, no, 0 potential. Yeah, that sounds right. Yeah. So, think of it like the multiple choice portion of the timed assessment. Although I think these questions are easier. So let's see. This is a pretty simple question. So let me just post this to ChatGPT and see if ChatGPT will just spit out the answer to me or give me like a follow-up question to kind of guide me along the right path. We'll see. Determine the distance per vibration. Okay. 2 centimeter apart. Okay. Calculate the frequency, moves at this speed. The frequency of vibration would be number of vibrations per second. Speed divided by, okay. So I think everyone should be able to just do the calculation. I want to ask ChatGPT a follow-up question. So speed, so 13 meters per second divided by 0.02 meter, convert the unit, is gonna be, so let me make sure I can do this correctly. Is that correct? Maybe. The easiest to trap for me is the kind of questions where I think I can do the mental math, and if it turns out to be difficult, then I'll attempt to the mental math and get it wrong. So I'll ask this question. So I got the right answer, but I'm not sure where the um, distance per vibration comes in. Why distance and not time? Because I think this is an unusual setup for oscillation. When we do waves next week, then there will be more natural connection to distance. But here, understand frequency in this context. Frequency is determined by how often a crevice passes a given point in space. Yeah, each time creates vibration. Yeah, distance between crevices. Right there. There's one vibration each time up. Yeah. So I think this is a good explanation, like trying to get how, like a idea of a cycle, one vibration, and frequency formula is number of events, number of cycles, vibrations. Yeah, yeah. So I think that's, yeah. I think that's good. I think this makes sense. I have seen 2 pi in a lot of frequency formulas. Why shouldn't there be 2 pi here? But it's specific to rotational or circular motion. I guess it could come in the context, although not exclusive to that. If you have formula for angular frequency and you're converting that to frequency, then there will be 2 pi coming in there. Oh yeah, angular frequency. And yeah. Now, with the angular frequency, the thing to be careful about is sometimes you could have an angle that's associated with like a circle. That I call that physical angle. Sometimes you could have an angle like a phase angle, like angular frequency of a pendulum or mass on a spring motion. There's no circle there, but you can still have what we refer to as a phase angle. You just have to watch out for it. Yeah. Yeah, so, all right. Thank you. That all sounds good. So, let me pick a question where I might attempt it for a bit and then make some plausible mistake and have ChatGPT correct it. Yeah, let's. So I'll imagine someone who has difficulty associating correct formulas with the right formulas, right situations. Because so this first question is asking for the force constant, right? And you have seen force constant of a spring in 2 different contexts, at least. One is what you are seeing in this immediate chapter, where there was a derivation done for angular frequency of a spring, so mass on a spring, and that angular frequency was given by square root of k over m. That's one. And the other context, which you should remember, is the Hooke's law, where spring force was given by minus k times delta x. And to answer part A, it's this second context that you have to remember, because so far they haven't given you any frequency information, but they have given you enough of the length information, information that can be connected to forces to kind of make use of this. So suppose I have someone who kind of forgot what we covered in chapter 5 and 6 and are just stuck with what we have covered in chapter 15. And let's ask ChatGPT, where do I go? I think I'm stuck. I have this question next, and I think I'm stuck. I have the formula for angular frequency, which has a force constant k in it, but I don't know where to go from here. And actually, for this question, I don't think you are ever going to use this because they don't ask a frequency question. You gotta set up a system of equation and do something else. This is actually a hard question, so let's see if a ChatGPT can help me test a student through it. Yeah. So it's two different masses, corresponding lengths. We are asked to find force constant and natural length of the spring. Yeah, set up the force equation. Yeah, so that's the correct equation to use, and set up the equations for each mass. Yeah, you have to set up a system of equations, and then you have to solve. I think I understand what you are saying. Shouldn't I use the formula for the angular frequency though? And the answer is no. It just doesn't come into the question. Yeah, typically use oscillations in this problem though. Yeah, even though we are in oscillations chapter, I think this question is in the chapter because it involves springs, and one setup in which you get oscillations is through springs. So yeah, I mean, great that you have the formula memorized, but you don't have to use it, or rather, in this context, it doesn't come in. Um, Sometimes you'll just have that. So let's see. I think so. Imagine I understood all this, and I think I can write that down. Yeah. So um, so after having read it through the explanations, I can start with let me actually, sorry, create some space where I can write cleanly. Yeah, good. So I got this 0.33 times 9.8 is equal to k times 0.250 minus L naught. 2.19 times 9.8 is equal to k times 0.920 minus L naught. And let's see. Let me imagine making some algebra mistake that's hopefully plausible. So I'm going to make a distribution mistake. So in simplifying this, I'll do this one correctly. So it's gonna be, I want to just simplify the left hand side, 0.33 times 9.8. So 3.234 is equal to, I'll do this correctly, 0.250 k minus L naught times k, and I'll make the mistake on the second line and then proceed to solve with that mistake still in place. So the left hand side should be 2.19 times 9.8, 21.462. 21.462 is equal to, and as I distribute k, I'm just gonna do it for the first term and forget to do it for the second term. It's the kind of algebra mistake that happens often enough, and you should be able to catch it when you do dimensional analysis. And one of the things that ChatGPT is doing that I don't like is that it's omitted all the units. So dimensional analysis won't help you here. And so here, as it's asking for the force constant, so let's say we are eliminating L naught. So I'll solve the second equation for L naught. I'll get L naught is equal to 0.90k minus 21.462. I can plug this into the second equation and combine. Let me just make a little more space here. I have 3.234 is equal to 0.250k minus, and then this thing here. Oh, when you get quadratic equation, that might be a hint that there's a mistake, but it's a soldier on 0.920k minus 21.462 times k. So you get for the linear term, you get 0.250 plus 21.462. Again, I'm making a mistake on purpose. 21.712k, and then minus 0.920k squared, 3.234. Let me say use Wolfram alpha, and then using Wolfram alpha, I should get two values of k, and I'll just say I pick the positive one is equal to 21.712 times x minus 0.92 times x squared. Solve for x in, and I think Wolfram alpha I'll understand and solve for x. Yeah. Oh, I see. Two answers. Let's get the one at the high end. So one at the high end. High end. Yeah. Well, I'll just have both values. X is equal to. I think they are both positive. So 0.1499, or the other one, 23.45. I think this is plausible. So, you plug in either one and it's going to be wrong because I made a mistake in algebra. So that's wrong. And I try 23.45. That's wrong. And so now my question to ChatGPT is, hey, I think I did this right, but the thing says it's wrong. What am I doing wrong? And this is the kind of scenario where I can imagine generative AI really being helpful, because mistakes like this are frustrating. You put in a lot of time, it keeps saying it's wrong, like, what are you doing wrong? And it's the kind of thing, if you brought the question to me at office hour, or asked me the question via Canvas message and show me all the work, then I can read it through it and correct it for you. And now, unless you are coming to my office hour, I'm not responding in real time. Generative AI can reply in real time. So I'll say the system keeps saying my answer's wrong, and I think it should be right. I double checked it, maybe. I'm right? Let's see what it does. Put in a lot of work, yeah. And also generative AI is pretty encouraging. It's always polite to you. It doesn't call you names, there's a lot of work. Double check the setup to make sure. Yeah, with the equation. Yeah, solve the equation by eliminating. It looks like there might be a simplification is or a minor error. So, it's not. So I guess seeing this far, you might be able to, oops, you might be able to see for yourself that, um, like if you saw this far and comparing it to this, you might realize that, oh, I forgot K there. Now, if you didn't, then it's making a suggestion that could be interesting. So it's saying, since you are using Wolfram Alpha, let's try plugging in the simultaneous equations directly there. How? So let's say you don't know how to do that. So I can ask, how do you plug in the simultaneous equations into Wolfram Alpha? I've only used the Sage method before. Does it? No. Wolfram Alpha doesn't really have a specific language. So, let's see. That's interesting. All right, we'll do that. And Wolfram Alpha, unlike Sage method, will understand the implied multiplication, so that might just work. Let's give it a try. Yeah, I think that's right. Solving for K and all that. Yeah, that's great. That's great. So K, let's just let's see. So that's 27.21. And this is now this is gonna be in meters, I think. Yeah. So you have to, or let's make a mistake here. Not notice that it's in centimeters. Put this in and get it marked wrong. So we'll do that. Submit it. One will be right, the other will be wrong. And then I'll ask again. Oops. All right. I hope he copied it correctly. Let's see. Alternative setup. If you're getting an error, okay. Interpret the results. Okay, make decimal point correctly. Or avoid me. Okay. All right. I think that worked, but it says my donut is still wrong. And can it point out the difference in units? Yeah, checking the unit. Yeah, meters. That's converted. Yeah. So this is the way in which generative AI can be helpful. So so if you are getting frustrated at this step with just your answers not working, then one thing that ChatGPT can do is suggest some ways where you can get the correct answer. One, this is the route we've gone, and let's say since we've gotten the correct answer, let's say now we are actually interested in more of the other thing it was suggesting. It was suggesting or I can help you walk through this manually here to verify. So I got the right answer, but can you help me figuring out what mistake I made in my algebra? I wonder if it'll remember the screenshot that I pasted. Your original equations. No, I didn't start with these equations. So yeah, I think ChatGPT is a little bit, it's the kind of thing. Yeah, yeah. So it's telling you these steps, but I think noticing a missing letter like that might be beyond what ChatGPT can do right now. So here it'll be up to you for you to kind of look at these correct equations and realize that you missed a K. Yeah. Yeah. Sometimes, spotting a exact place you made a mistake can be more work than necessary. So I think it's fine. Okay, we got 8 minutes, probably enough time for one more question. Let's find the let's do this pendulum question. I've just done this, in a separate video, but let's see without looking at the hint how ChatGPT guides it. Which of my two solution approaches ChatGPT prefers. Because I don't know. I think just plugging in numbers is the simpler approach. But hints guide you toward taking derivative and all that. Let's see which way ChatGPT goes. Thank you. I got this next question, and other than omega is equal to square root of g over L for pendulum, I'm pretty lost. It's here the formula. Yeah, from that, from what I've written down, you can get to period. Good. Leading period of timekeeping gains time. That means correct this. Fractional length, changing engine length. Oh, okay. Yeah, I guess. All right. So that's the standard approach. Although, okay, this I don't know. So, in my other video, this is what I derived after like 10 minutes, which, could have been shorter, but also, this is, so this is what I recommend that you do. If you had a question like this, read through it and you hopefully understand where this comes from. Okay, keep reading. And when it says this, I think for most people, your reaction should be, I don't know where this comes from. You gotta ask. So let me ask. Okay, I'm stuck at step 3A. Screenshot attached. How are you getting that formula? You should always be asking that. If it's a formula in the textbook, you should be asking yourself, how is the textbook author deriving it? If it's a formula in a ChatGPT, you should ask it, hey, how did you get that formula? Okay, period is this. Rewrite it in a form that's easy to differentiate. Sure. Differentiate with respect to L. Okay, do that. It looks like it may have used the chain rule. So it did the outside and then the inside, which is 1 over G. You can do that. It's fine. You could also just, pull out G so that you just have square root of L. Simplify. And from here to that simplification, I think is fine. So let's play a little bit slow and I'll write this down. So what I'm writing down is I have the last equation it's written, which I think I understand. And then I do the thing that it's telling me to do, which is divide both sides by t. That actually gives you a pretty ugly expression. 1 over t times dt over dl is equal to pi divided by square root of gl. And you might even go this far, so not playing deliberately dumb, move dl over to the other side. Maybe something like dt over t is equal to pi over square root of GL. Oops, I forgot T there. Now, yeah, T there is fine. Let me just rewrite here so it's not so confusing. Pi divided by T times the square root of GL times DL and then you say, I don't. So I'll paste this in and say, hey, I don't get the expression you had before. Uh, I followed those steps, but um, I don't get what dt over t is equal to 1/2 dl. I get what's attached, and it might tell me to, on the right hand side, plug in the expression for t. Yeah, I did that. Oh wait. Oh, parse error. Mm, try again. Oh, keeps getting stuck. Uh, oh wait. So here, yeah, and substitute t into dt over. No, that's the wrong step. Um, for with the canvas maybe. Logarithm. Oh wait, this might actually give you something that's interesting. So I don't think this is the simplest way to approach this, but I mean it is. It might be a way. So yeah, it's kind of using something that's similar to implicit differentiation, I think. But so the on the left hand side, derivative of the outside is 1/t, and then you got derivative inside, derivative of t itself, which is dt over dl. You have that. And the advantage of this approach is that you have preserved an expression for 1/t. Fine, which is what you want. And on the right hand side, this is constant 0, and here you got 1/2, and then derivative to the outside, which would be reciprocal of this, g over l, and then derivative to the inside, 1/g, g is cancelled, so you get that. Yeah. So yeah, that's one approach. So both of the approaches, the one that I did in the other video and the one that ChatGPT is doing here, they both require a bit of poorly motivated step. In my case, it was multiplying by 1, where I express period two different ways. One with the symbol for period, and the other one with the expression for the period. And they simplify in a way to give you this. Here, you are doing something weird. Just take the natural logarithm and then take the derivative. And I guess what I would say is that this is where, the saying practice makes perfect comes from. These kind of steps that you might take. I think the real motivation for these steps is that you've seen it done before. You've seen it done before where if you have an expression like 1 over the function that you want, that taking the logarithm first helped. Then that would be the motivation to take the logarithm here. And in my case of multiplying by 1, that's a common simplification technique that I learned as a physics major. It applies in a lot of different situations. So I just say practice makes perfect. So practice. and I think this is a good practice, good opportunity setting to practice with someone you can do back and forth with. And this particular approach, I guess, I wouldn't have thought of it. Something new I learned. I don't know if ChatGPT will ever use the approach I was using, multiplying by 1, but different, techniques, different styles. So I'll just end up here. All right. Thank you. Oh, and maybe this reinforcement. So All right, so I think that's enough. We are over time. Thank you so much to those of you joining. I'll see you next week.